What's up, CoderByte? Welcome back to another data structures and algorithms video. I'm Elizabeth, and this is going to be our last video in our dynamic arrays series. This is another problem that I think you'll find all over the internet, but remember, I think that those are the ones that it's super important to know inside and out, because if you get them, when you get them, it's really important to demonstrate that you have mastery over some of these foundational skills that really make up being a really good developer. So let's get into this week's problem. Okay, let's talk about this week's problem. A group of pesky hackers has been plaguing Liz at her day job for some time now. They detonate ransomware on networks pretty regularly, which usually gets caught by the security engineers in time before they wreak havoc on her clients' networks. Their signature move is to leave a ransomware note with all of the words reversed. She is tasked with writing a function to quickly decode their ransomware notes that can be run in place on the notes. Okay, so let's take a look at some examples of what these ransomware notes might look like. So here I have const message, which is just convenient because we're going to be passing it into a function. So, the ransomware notes don't quite look like this. But as you can see, it's an array of characters. And if you see, the words are not backwards themselves, but the actual message is backwards, right? So this says else with a space or money your all us give, right? So if we read that backwards, that will be give us all your money or else. This is a very mature ransomware note, as you can tell. So our task is to take this array, right, and make it into something that looks like this, right? So this is the reversed message. Give us all your money or else. Now, remember, I want to stress here that the words themselves are not backwards, right? It's just the ordering of the words that are backwards. Okay, so let's talk about some approaches that we could possibly take here, right? So generally to change the ordering of something in place or reverse something, you're going to want to be swapping things, right? You're not going to be like taking something off of the array and then putting it in or making a copy of it or creating a new array. You want to be taking one thing and taking another thing and actually switching them in place, right? Now, I think in this problem, which is a funny example of a problem, you can imagine that we want to do this in place because this is going to be run on the servers that the hackers are actually on, right? We want to be doing this. We don't want to be using up memory to decode the ransomware note. We just want to know what the ransomware note says. Okay, so it has to be in place. That's important. Otherwise, you might be able to do something like, you know, figure out all the words based on the boundaries of the words, right? And the boundaries of the words would either be in between spaces or at the beginning or end of the array. You could keep track of, what word came in what order, and then you could create a new array just by reversing the ordering if you saved where the index of each word in the array, right? That would be an easy way to do this, but you'd be creating a lot of new data structures, right? You'd have to track the ordering of all of the words, and you'd also have to create a new data structure to hold the new message. So in this case, we're not doing that. We're doing this in place. I just want to make that very clear. So let's talk about an approach here. So here's an example of, words not in an array, right? The words are just, let's talk about what we would do intuitively, right? So outside playing loves dog though, right? This is the dog loves playing outside backwards. So to swap things, we might take the last word and the first word and swap them, right? So what would that be? That would look like the playing loves dog outside. And then we can do it again, right? We can move inwards towards the middle and continue to swap things until we get to the middle. So then finally we're in the middle. You can imagine that we have some sort of left pointer and right pointer, or left index and right index, and we're just swapping things until left and right index, while the left index is still less than the right index, right? And until that case is met, keep swapping things. So that's pretty easy, right? We have the dog loves playing outside. So let's look at our message again here. This is the ransomware note. else or money, your all, us, give. So if we tried to do something like this in code, right, which is basically just taking this last one, right, give and else and swapping them, and then us and or and swapping them, and then finally all and money and swapping them until we got to your, which is the middle, right? So we could kind of do that, but the problem is that in order to keep track of where our left index and right index are, it would actually be very difficult to swap words that weren't the same length, because we would have to move the indexes based on what words we're swapping with, and it could get complicated and confusing, right? It's kind of difficult to do this in place with when we have characters as opposed to full words, right? The hackers have made this difficult for us, and we can't just take one word and swap it because they're each of equal length, one, because they're both just one string. We have to somehow keep track of what are we swapping the words with, right? Is give and else the same length? Yes, that would be fine. Us and or, also the same length. All and money, though, that's going to mess up our indices and how we're tracking things. So what else can we do to kind of use this approach to swap things in place without having to keep track of how long the words are and what we're, when we're doing the swapping, so we can maintain those very clean, nice indices all moving towards the center. So I think the thing to notice here is that let's take a look at an easier case, right? Always break it down to something simpler. So forget the words part. Let's pretend the array is just one word, right? So this is my name, right? Elizabeth, backwards. So we can do that swapping thing, right? We can swap E for H, T for L, I for E, etc. until we get to the middle, and that will just work, right? We'll end up with Elizabeth in an array forwards. So let's take a look at our message again. So here's another one. I changed the message to be the nicer one instead of the, immature ransomware one. So this is outside playing, loves dog though, right? The dog loves playing outside. So what happens if we reverse all of the characters in this whole message, right? If we treated the whole message as if it was just one word, what would actually happen here? So what you can see here is that here are all of the words, right? And we've reversed them. So now the words are reversed as well. So this is almost an unintuitive step, right? Because you think, why would I reverse the words if the words are not reversed? Leave them, and then, right, we want to reverse something. We don't want to scramble things while we're unscrambling things. That's what you would think. But as you can see, as you reverse the words, what happens is we then get the words in the correct order, right? We're unreversing the words despite the fact that now the letters in the words are reversed, right? So now we have, if you can read backwards with me, the dog loves playing outside, which is very interesting, right? So now we've already accomplished what we wanted to accomplish, and now what we want to do is we want to unreverse or re-reverse, I don't know, whatever, the words themselves, right? So instead of having to keep track of how long the words are, what we're reversing with, we can actually just do the same character, just single character reversal twice, and then we can take each of these words and just unreverse them on their own, right? We can take the and unreverse it, just like we did with Elizabeth. Then we can take dog and we can unreverse it, and then we'll get dog. Yeah. Same with all of these, right? So I hope that that's clear. You'll see how we do this in code, but it's kind of a cool little, like, take a step backwards to take a step forwards algorithm. And, just to reiterate, so our algorithm is pretty simple. It's to reverse the characters of the entire message and then reverse the characters of each word again, right? So it's all in place. It's just loops. But what we're doing is we are swapping the characters of the entire message so that we get the correct ordering of the words. And then we then, in a second step, fix the ordering of each word as it appears. Again, I think this will become clearer once we code this out, but I thought this is a super cool algorithm because it's kind of like, it's like a trick when you sort of see, how are things acting. And it's a way of making a code actually very simple in order to actually decode the message. You all know the drill by now. As you can see, here is my JavaScript file in Visual Studio Code with some example test cases here. I have message, which is give us all your money or else or money your all us give. And then I have another message, which is the dog loves playing outside or outside playing loves dog the, right? And what I want you to see and notice here right away is that what I'm doing is I'm actually calling our functions, right, reverse words, on the messages, and I'm not capturing any return value, right, because I can just then log out the message because this is in place, right? We're not making a new array. We are changing the original array that we're passing in, right? And just so you know, this is a good tip just in general, that despite the fact that I'm using const here, and we're changing these things in place, const, as most of you will know, as opposed to let, means that you're not going to change the variable, versus let, which means that you actually will or can. You can actually use const for arrays and objects, and you can still modify the contents within. So that's just interesting and a good tip and something you can, impress your interviewer with, that that detail or nuance. Okay, so let's get started. Here is going to be our function, right? This is going to be reverse words, and this is going to take our message, right? Okay, so that much is simple. Now, remember, our goals here are, right, one is to reverse all the characters, right? And then two is going to be, right, find the word boundaries, right? And re-reverse the characters of each word. So what I mean by that is that we are going to reverse the entire message, right? The whole string. And then word by word, we're going to reverse that entire string. We're going to set the boundaries to be equal to the beginning of the word and the end of the word. And then we're just going to re-reverse those characters again to unscramble the scrambled word. So this, for me, I feel like makes the most sense to do this part, the reverse all the characters, to do in some sort of helper function, right? Because we're going to be calling that twice. We're going to call it once on the message, and then we're going to call it again on each word to unscramble the scrambles that we created. So I'm going to make a new function. And this is another really good tip for interviews. I think often in actual coding, we make a lot of helper functions, right? We encapsulate small bits of logic so that they can be shared across files, shared across different projects, whatever, it's a very clean way of organizing things. And despite the fact that you're in an interview and it really doesn't matter, you're just making one function and it's just to solve this problem, kind of, what's the word? Like, it's a fake testing environment. It's not really real. You're just making a one-off function. It's really important to kind of demonstrate that you understand like the best practices of what you would be doing if you were making this in a real life scenario. And often you would be encapsulating things in helper functions or methods or whatever. So, just food for thought. But here's our helper function, right? Reverse characters. And this is also just going to take an array, right? So that's going to be an array of characters. And this would be similar to, right, we can test this out, right? So this is going to be const my name. So this is going to be, right, Elizabeth. Ooh, let's see if I can do this fast. Ooh, this is actually kind of harder than I thought it was going to be. I-L-E. Elizabeth. Yeah, that looks right. Also, another fun fact, I spell my name with an S, but I spell Liz with a Z. Go figure. Anyway, so this is my name spelled backwards, so we can use that as our test for our reverse characters function. Okay, so I think for our reverse characters function, what we want to do is we want to basically have some idea of, right, our left index and our right index, and again, we're going to swap until we get to that middle point. So I'm thinking ahead, and if this was always going to be just, right, we were always just passing it an array with the one word, you can just initialize your left index, right, to be 0 and your right index to be the array.length, right, -1. Because you're always going to be working at the beginning and the end and just going towards the middle. But because we know we're going to be calling this eventually with just pieces of an array, right? Because we're going to want to be able to call this with just one portion, right? Because that's the whole point. If we just reverse the whole thing, we just undo what we did in the first step. We're going to want to only call this for a certain portion of the array. So I'm going to pass in a left index and right index. And that way, even though we're continuing to pass around the full message, we can control where we're reversing, the bounds of the reversal, if you will. So you'll see more why we're going to need this when we start to write the reverse words function, but for now, take my word for it. I think that's where we're going. Okay, so essentially, right, like I said in the slides, this is just going to be a while loop, right? While the left index is less than the right index, aka they haven't met yet, right? So while the left index is less than the right index, we basically just want to capture what's at the right index or the left index and then swap it with whatever is at the left index or right index and then, do that again, right? So we can say the let, like, I don't know, let temp letter. So this is just going to be until we're ready to do the swap in the other direction, right? Because you can't assign two different array spots in the same go. So let's say the temp letter is going to be the array at the left index. Nope. There we go. Nope. Okay. Now what we can do is we can set whatever's at that left index, right? I wish it would stop doing that. We can just set it to whatever is at the array at the right index, right? So the reason why we capture this in a temporary variable is because we overwrite it immediately right here, and we need to remember what was there, right? And then, because we remembered what was there, we can just set whatever is at the, whatever was at the left index, which now we know is the temp letter, to be what's at the right index. And that's basically it. And then we can increment our left index, right? And we can decrement, I don't know, our right index. And that should do it. Again, we don't have to return anything because we're modifying the array in place here. So that's important to note. Again, your interviewer, if they say in place, they're going to want to make sure that you solve it in place. If you solve it not in place, then it's useless, because what they're really testing here is this specific skill. So keep that in mind. Okay, so here we have our reverse characters. Let's test it out here. Let's say reverse characters my name, and let's see what we get. Console.log my name. I'm going to just comment that out. And let's say node. Okay, so we did not get what I thought we would. So let's see what Oh, I know why. Because we did not pass in any left and right index. So it didn't do anything, right? So let's pass that in right here. So our left index is going to be 0, and our right index is going to be my name dot length minus 1. Okay, try that one more time, and there we go. Elizabeth. I was terrified that this was going to print out and it wasn't going to be my name, and I would be embarrassed that I can't even spell my own name backwards. But it's a long name, so you know. Okay, so that works. Excellent. So we could get rid of this. Okay, so that is our reverse characters, right? So we have done that. So we haven't actually written the code for that, but that is very simple, right? We can just say we want to reverse, right? Reverse characters, the message with, again, we have to remember to pass in that left index and that right index. So that's going to be 0 and then message.length minus 1. And again, we don't have to capture anything because we're doing this in place. This is modifying the actual message that gets passed. Okay, so we now have, let's console.log the message, just so we can see what we got here. I'm going to uncomment out one of the test cases. Let's see what we get here. Okay, so it's printing twice because I printed it here and also after I called the function. But here we have our message, which is the correct ordering of the words with the incorrect reversed ordering of the letters. So we have give us, that's in a different line, all your money or else, right? And the words themselves are still not in the right order. I mean, the words are in the right order, but the letters in the words are now in the backwards order. Okay, so that's exactly what we expected. Okay, so what comes next? We want to find the word boundaries, right? And we want to call reverse characters again on each word. And we want to do it on a per word basis to maintain the ordering that we've now corrected in the words, right? So that's relatively straightforward, right? What are the word boundaries? The word boundaries are either spaces or the beginning and end of the array, right? That's how we know that we've kind of the beginning and the end of a word. So I think here what I'm going to do is I'm going to do some sort of loop, right? And this is going to basically loop through this message, passing in we're going to call reverse characters every time we hit another word boundary, right? So let's say let I equals 0, I is less than the message dot length, I plus plus. And here what we want to do is we want to check, right? We want to say if the message at I is equal to a space, right? Or I is equal to the message dot length, right? That's how we know that we've hit the end of a word. And already I know that I made a mistake here because we want to actually capture the end. We want to know that we're at the end. And we can know that we're at the end by checking whether or not I is equal to the message length. And I will never be equal to the message length if we do only a less than. We have to do a less than and an equals. Okay, so now here, and the reason why we're doing a less than equals, right, is because we always want to be looking ahead of the word because that's the boundary. And then we want to reverse everything before the boundary. So if we get to a space, we want to always call reverse characters from the beginning of the word to whatever the boundary is minus 1, right? So that's why I'm doing that. Okay, so those are our boundaries, right? And then we want to call the reverse characters function, passing in that entire message, again, because we're not slicing and dicing here. We're not taking new arrays, making new arrays of the individual words and returning them and then adding them back in. We're maintaining that we are only doing operations on the message and we're changing the message and not creating any new structures. So we want to pass in the message, and then we want to pass in the word start, right? Now, how can we keep track of the word start? So we probably want to initialize this at 0, right? So this is going to be let word start index at 0, right? And then we can move this after every time we find a word, right? Then we know that the next word is going to start after the boundary, right? After the space, and it's not after the end of the array, because at that point we're done. But after a space, that's going to be the next word beginning. So here we can pass in the word start index, and then we can pass in I minus 1. And again, we're passing in I minus 1 because we've hit a boundary, and now we want to reverse everything before it. Because if we reverse things with the spaces are all going to be messed up. We only want to reverse the word itself. Okay, so after we call reverse characters on each word, all we have to remember to do is then update that word start index. So this word start index is now going to be 1 after the boundary that we found, which will be a space, right? So this is going to be I plus 1, right? And again, I think the thing that trips people up here is this part, this part, this part, and this part, right? It's realizing what and where our indices are and what exactly we're tracking. And so really take a second to think about how this is happening. We'll walk through this. We can print out what's happening just so we understand exactly where those boundaries are and what we're passing. Because before you know it, you might be calling these functions and you're one off and the message gets ruined because a space is in the middle of a word, or there are 2 spaces and 2 words with no spaces between them, whatever. So definitely, we'll take a second to go over all of that, but I want to just kind of reiterate what's happening here. Okay, and I believe that's it. And again, we don't have to return anything because we're modifying the message in place. So let's see if that works. And I think it did. Give us all your money or else. And then the dog loves playing outside. Okay, cool. So I do want to, like I said, log out exactly what's happening here because I think it's important, right? So let's see, how do I want to do this? Because I don't want it to be too many console log statements. So if we get in here, let's console log out, right? We can do the message. We can console log I, and then let's console log the word start. Nope. Okay, so let's see, and let's only do one of these. Okay, so here we have our message, right? And our loop goes basically until we get to that first boundary, right? So we start with our word start index of 0, and I is equal to 4. So let's see, 0, 1, 2, 3, 4, right? So that makes sense. That's that first space. We pass that in to our reverse characters function, and we basically reverse the characters, right, from the 0th index to the 3rd index, because what we pass it is I minus 1, right? So that will take care of not capturing this space and only reversing the word, right, as we can see here. Then we increment our word start index to I plus 1, which will be 5, right? So that's how we then skip this again for our next iteration, and we get to us, right? So that's going to be our next thing that we do. So now we have our word start index at 5, I is equal to 7, so that's 0, 1, 2, 3, 4, 5. Perfect, we're starting at the S. and we're ending at the 7, which is this space, right? And we repeat the same thing. We pass in now to our reverse characters function with the left index starting here and our right index ending here, and we just reverse that and we get us, etc., right? So again, I invite you to play around with this. I'm not going to go through each one, but just to watch the indices move so you understand kind of how we're getting we're actually maintaining the proper bounds for our words and also our message. So that's it. Again, this is a pretty simple algorithm in code, but I think that conceptually, the difficult thing here is to do this in place. The actual swapping and the kind of maintaining where you are. The thing that's the hardest about this is understanding your indices and where they are, what they're representing. Because sometimes when you have a bunch of things that you're keeping track of with indices, it's easy to lose track of. Like, I know I've so often been writing a function and I'm like -1, +1, and I kind of try it, and it never really works if you don't really understand what you're doing. It's hard to actually get it right accidentally. So I think it's really, really important to understand what your indices are, where you're keeping track of things, what the bounds are of the words, etc. So yeah, that's it, and I hope you enjoyed this one. I want to close out just by talking briefly about the big O of this algorithm. It is a linear big O of n, where n is the length of the message, because you're really only ever looping over the message, right? You loop over it maybe multiple times, but you can drop that constant. So that's really cool. And in terms of space, you're not really taking up anything, right? You're not making any new structures. You briefly hold the value of what's at one index in the array in a temporary variable, but this is very cheap in terms of space, which is super cool. So yeah, I hope you enjoyed this series all about dynamic arrays. I think it's really important to know these skills, these foundational skills, really like the back of your hand, like the front of your hand. What's the idiom there? I don't know. I think it's the back of your hand. Regardless, you should know them inside and out, because these are the things that you actually will be using on the job, as opposed to a bunch of the more difficult, like graph, problems, or binary heap, or I don't even know what, all the things that you probably never use again after you're studying for your interviews. These are the things that are actually, they're very useful. It's good to know how to make a loop, how to loop over data, how to organize data, and all of that fun stuff. So I hope you enjoyed this series. Next week, we're going to be starting a brand new series all about system designs, which I'm really excited about, because again, this is going to be a series that is really, really relevant and applicable. It's really applicable to your actual job after you get the job, right? After you pass the interview, these are the things that are important for you to be thinking about in a long-term way for the rest of your career. Some of these problems are really kind of how you make the move from maybe a more junior developer position to a senior developer position, organizing systems, designing systems that scale, that work in broad strokes, and being able to talk about them with other people. So I'm super excited about this new series, and I really can't wait to see you all there. Have a good week, guys.